Hi, welcome to this lesson on quadratic functions. We've already had a look at solving quadratic equations, but what we're going to have a look at is what a quadratic function looks like on a graph. So we know something about linear functions, hopefully. You'll know the likes of a line with the equation y equals mx plus c. We know that if you plot a line, for instance, y equals 3x, in other words, the y coordinate is always 3 times the x coordinate, then all those points will lie on a straight line or a linear function. Linear just meaning in the style of a line. So for instance, when x is 1, y is 3, so the point 1, 3 lies on the line. And when x is 2, 2 times 3 is 6, so the point 2, 6 lies on the line. 0, 0 lies on the line. The point 1/2, 1 1/2 lies on the line because that's 3 times a half. So in other words, there's that relationship between the x and the y coordinates, always a straight line. Quadratic functions are different because of this squared term, okay? And you get this special type of curve. So I'll show you why it looks like this. We've got y equals x squared on the top left here. That's the mothership of quadratic functions, very basic. Y equals x squared. So in other words, what we're dealing with here is when x is 1, it 1 squared is 1. The y coordinate is also 1. When x is 2, 2 squared is 4, so y is 4. And when x is 3, 3 squared is 9. So all these points lie on the curve, 4, 16, 5, 25. And you notice that because it's squaring, the y coordinate is getting bigger quicker than the x coordinate. That's why we get this steepening curve. But look at the left hand side of the y axis here. When x is -1, the y coordinate is still going to be +1 because -1 squared is +1. When x is -2, the y coordinate is still +4. And when x is -3, the y coordinate is still +9. So the two different x values have the same y coordinate, and so you get this repeating level here. That's why it makes a curve. Okay, and they all either have a bottom point or a top point where it kind of turns, and we'll talk a bit more about that later. But the type of curve that we've got here is a parabola. Okay, parabolic curve. Really important curve in mathematics because you find them everywhere. If you stick a light bulb next to a wall, it will make a parabolic curve. Although you probably didn't notice, every time you go through the drive-thru at McDonald's, you pass by some parabolic curves. And if you were a freestyle skier, then you would be making the shape of a parabola. Anytime something is thrown up or goes up in the air and comes back down, the force of gravity creates this parabola. It could be in design or in architecture, or the natural droop of cables, like between the two tops of the bridge mounts there. As the cables droop down in the middle by gravity, it makes a parabolic curve. Inside of a satellite dish is a parabola to catch all the waves, and with a couple of balls at the end, golf ball hit up, it's going to make the shape of a parabola because the gravity pulls it back down. And even the bouncing of a ball kind of stop. This is one of these kind of stop go motion, or the kind of time lapse things where you can see the parabola as the ball bounces off the ground. So these are all real parabolas, and mathematics is about describing real life. So we use parabolas a lot. So what's that got to do with what we've done before solving quadratic equations? Well, look at this quadratic equation, x squared minus 3x equals 0. If you've done that bit, you'll be able to work with me. If not, don't worry about it. So we've got a common factor of x, and that leaves us x minus 3 in the bracket. Okay, we've factorised it. Because one number multiplied by another gives you the answer 0, we know that either the first number has to be 0 or the second number has to be 0. So we can solve that equation to say that the solutions to that equation are either x equals 0 or x equals 3. Okay? In other words, substituting 0 in for x or 3 in for x will give us the same answer. Great. Well, look at this graph on the right hand side. It happens to be the graph of y equals x squared minus 3x, which is kind of the same term as the equation that we started with, except it's got an equal 0 as an equation. But have a look at this, because x squared minus 3x is how you get the y coordinate, and all we are saying in our equation is we want 0 to be in the equation instead of the letter y. In other words, we're interested in what happens when y equals 0 on the curve. In other words, what coordinates, what points on the curve have a y coordinate of 0? Well, you have a y coordinate of 0 when you're on the x-axis. Anywhere along the x-axis has a y coordinate of 0. And have a look, the curve shows us that the point 0, 0 lies on the line, and the point 3, 0 lies on the curve, sorry. So in other words, the y coordinates of all the points are 0 when x equals 3 and x equals 0, which happens to be, whoa, the solutions to our equation. So instead of doing the algebra, we could actually just look at the picture. Let's check another one here. All right, solve the equation x squared plus x minus 6 equals 0. We could do some trinomial factorizing. If you think you could, then you could factorize that, and you could end up with this. And you could say either x plus 3 equals 0 or x minus 2 equals 0, which would give us x equals negative 3 or x equals 2. Or we could just say, well, if we want 0 as our y coordinate, we just look at the curve where the y coordinate is 0, where all along the x-axis we're looking for points on the curve where the y coordinate is 0. Look, 2, 0 is on the curve, and also negative 3, 0 is on the curve. They both got a y coordinate of 0, and so they happen to be the values of x that make the y coordinate 0. X equals 2 and x equals negative 3. So we can solve quadratic equations graphically just by looking at the graph. So, interesting graph moment. You've seen the fact that pictures of parabolas, sometimes they go to a lowest point and then they kind of go back up from both those points. Sometimes it gets to a top, a wee hill. Okay, what's the difference between these? And interestingly, I've kind of missed the actual key point in all of this when I was putting these in. The difference is a negative sign. If the squared term in a quadratic function is negative, then the shape of the curve is inversed. Okay, so when x squared is positive, we've got this lowest point, and when x squared is negative, we've got this highest point it comes down to. And of course, the classic way to remember it is when x squared is positive. When you're positive, you're feeling happy, so you smile, and it makes a smile. And when x squared is negative, when you're feeling a bit negative about something, you might be frowning, and it makes the frown shape. So there we go. That's an easy way to remember that. Okay, so have a go at solving these equations by graphical means. It simply means you could write down the equation, and we can actually just work out the solutions from these graphs by simply recognizing the point where it cuts the x-axis. So have a go at it. You can pause it if you want to just get it right. Where does it cut the x-axis each time? Because that's our solutions. Okay, so let's have a look at the first one. Solve the equation x squared minus 3x minus 10 equals 0. There's our curve of y equals x squared minus 3x minus 10. What values of x will produce a y coordinate of 0? The values of x, the y coordinate is 0 on the x-axis. So there's my 2 points here. So I can literally just write down the solutions are x equals, well, what's the scale? Each box is 1 there. So it's negative 2 or x equals positive 5. For the second one, you notice that we've got a maximum value here because it's a negative x squared. We've got a frown, negative x squared, but we can still read off the solutions in the same way. So for the values of x equal to 0, we want when x is -4, the y coordinate is 0. So -4 is a solution. And when x is looks like 1, then we also have a solution. And of course we can check that by swapping in 1 into the original equation. 4 minus 3 times 1 is 3. 4 minus 3 is 1. Subtract 1 squared does give us 0. So that's a solution. And the last one, harder to factorize. Therefore, the graphical solution is quite helpful in that way. This time you have to be careful with the scales, because we've got -4 is a solution, and we've got, that would be 1 and 2. So it's halfway between 0 and 1 would be +1/2. So our solutions are x equals -4 and x equals 1/2. Okay, so hopefully that's been a helpful start to the introduction of quadratic graphs. We're going to go on and have a look at how we can look a wee bit more some of the key terms of a quadratic graph. So that's on the next video. So watch that once you kind of got to grips with the graphical solutions. Okay, hopefully that's been helpful.